Hello, and welcome to Summarize Science. Today, we're diving into a paper from NVIDIA called Nemotron Elastic, which presents a groundbreaking way to make powerful AI models much more efficient. You've probably heard of models like Llama or ChatGPT, but you might not know how incredibly expensive they are to create. The big problem is that when developers want to offer different sizes of a model, say, a small one for your phone and a huge one for a data center, they usually have to train each one separately from scratch. This process consumes massive amounts of energy and costs millions of dollars for every single model size. It's like having to build a completely new car from the ground up just because you want a compact version instead of an SUV. Nemotron Elastic offers a brilliant solution. What if you could train just one giant parent model and have smaller, fully functional models nested inside it? That's exactly what this framework does. It uses a clever component called a router that learns which parts of the big model are the most important. During deployment, this router can instantly slice out a smaller, optimized model of a desired size without any extra training. All these smaller models share the same core brain as the parent, making them incredibly coherent and capable. So, how much more efficient is this? The results are staggering. This graph shows that as you add more models to the family, the cost for Nemotron Elastic stays flat. Meanwhile, other compression methods see their costs rise linearly with each new model. Let's look at the numbers. To create 6 and 9 billion parameter models from a 12 billion parent, Nemotron Elastic required only 110 billion training tokens. That's a 7-fold reduction compared to other state-of-the-art compression techniques. And compared to training these models from scratch, it's an estimated 360 times more cost-effective. The memory savings are just as impressive. Because all the models are nested, you only need to store the one large parent model on your server. This research shows you can get 3 models for nearly half the storage space of 2 traditionally trained models. So, to recap the key points, Nemotron Elastic allows for the creation of multiple AI model sizes from a single training run. This is achieved by embedding smaller subnetworks inside one large parent model, which can be extracted on demand. The result is a massive reduction in training costs, energy consumption, and deployment memory. What does this mean for the future? It could democratize access to powerful AI, allowing smaller companies and researchers to build and deploy sophisticated models without needing a supercomputer. It also means we can have more flexible AI systems that dynamically choose the right model size for the task at hand. This work represents a huge step towards making AI more sustainable, affordable, and accessible for everyone. Thanks for watching Summarize Science.